Hello, this video is going to show you how to factorise polynomials. So I'm going to look at an example of factorising a cubic. So let's take, for example, the polynomial 6x cubed plus 17x squared minus 4x minus 3. Now, to make the process easier, the communication, I'm going to give this cubic function a name. I'm just going to call it p of x. Now, what we want to do is find our first factor, and the process that we use for that uses a thing called the remainder theorem. And that tells us that if we find a value of x that we substitute into p of x, and if p of x equals 0, so let's say, for example, we have x equals a. If p of a equals 0, then that implies that x minus a is a factor. That's basically the remainder theorem. So what we're doing here is we're going to try use a little bit of trial and error to start with to find our first factor. Now, we can be a little bit cluey about it. You only really want to look at numbers that are a factor of this number here. So the factors of -3 are 1 and -1, 3 and -3. So that sort of narrows it down. So it tells us there's no point putting 2 in here and evaluating because it's not going to equal 0. It's not going to work. So I recommend just thinking about those factors, starting with your small ones and trying it out. Sometimes you can see whether they're going to work or not before you sub them in. So for example, if I try p of 1, we would have 6 times 1 cubed plus 17 times 1 squared minus 4 times 1 minus 3. Now I can see here that's going to be 6 and 17 is 23. There's no way, I'm not taking away enough. That definitely doesn't equal 0. We could try p of -1. So 6 times -1 cubed plus 17 times -1 squared minus 4 times -1 minus 3. Now, just take a little further before we can see whether it works or not. That -1 cube's -1, so that would be -6. That'll turn to positive, so plus 17. That'll turn positive, plus 4 minus 3. Once again, I can see that that doesn't equal 0. So that's not the number that I'm looking for. Now, I could save myself the trouble of putting 3 in here because I can see that, like, I've got two bigger positive numbers here. I'm going to end up with too much positive and not enough negative to balance it out to equal 0. So I'm not even going to worry about putting 3 in. I can see it's not going to work. So I'll try p of -3. So 6 times -3 cubed plus 17 times -3 squared minus 4 times -3 minus 3. Okay, -3 cubed is going to be -27. So that would be 6 times -27 plus 17 times, that would be 9. That will be plus 12 minus 3. Now here, we do need to remember that this sort of question would very easily be on your tech-free exam. So you need to get used to being able to do the mental arithmetic for this as well. So here, the way I'm thinking about this, I would think to myself, well, 6 20s are 120 and 6 7s are 42. Now I know it's negative because we've got a positive times a negative. So that's going to be -162. Here, 9 10s are 90, 9 7s are 63. So that's plus 153. And if I simplify that bit, I get plus 9. Now I can see I've got -162, and here I've got plus 162, so that equals 0. So with using the remainder theorem, that tells me then that x minus -3, so in other words, x plus 3, is a factor. So I've found my first factor, and now we're going to use polynomial division to divide that factor out and obtain a quadratic. Now, if you can't remember how to do polynomial division, you can see another one of my videos on that to just remind you of the process, although I'll be showing you here anyway. So now I'm going to take our original cubic, 6x cubed plus 17x squared minus 4x minus 3, and I'm going to divide it by x plus 3. So I'm thinking x into 6x cubed gives me 6x squared, and I multiply that down. 6x squared times x is 6x cubed. 6x squared times 3x is plus 18x. And then I have to subtract that off to find my remainder. So 17x squared, or the 6x cubed, disappears, and 17x squared minus, oh, whoops, forgot the squared, minus 18x squared gives me negative 1x squared. Bring down my next term. And now I'm thinking x into minus x squared goes negative x. Multiply that down and I get negative x squared minus 3x. And then I'll subtract that off to get my remainder. The minus x squared minus minus turns to plus. That disappears. Negative 4x minus minus 3 turns to plus 3x, so that leaves me with negative x. Bring down the next term, the minus 3. X into negative x goes negative 1. Multiply that down and I get negative x minus 3, which when I subtract, I get a remainder of 0, which is what we expected because we already found out that x plus 3 was a factor. So now what I can do from there is I'll just pop over here and I can say that P of x is equal to x plus 3 times that quadratic, 6x squared minus x minus 1. So now I'm going to do a little thinking here just to work out factorising my quadratic. If you've gone a bit rusty on factorising quadratics, I have another video that would help you with that as well. But for now, so what I normally do is do a little table to help with the thinking. My AC, 6 times negative 1 is negative 6. B is negative 1. So I'm thinking what multiplies to give negative 6 and adds to give negative 1. So I can see that negative 3 times 2 is negative 6, and negative 3 plus 2 is negative 1. So that is the combination that I'm looking for. So I take my quadratic. I'm going to split that middle term into the two terms. So I have 6x squared minus 3x plus 2x, and then the minus 1. Now I'm going to pair up my first two terms, factorise them, and pair up the second two terms and factorise them. So here my common factor is 3x. And what I'd be left with would be 2x minus 1. Now here, when there appears to be no common factor, your common factor is 1. So what I'm left with is the 2x minus 1. And as we want, the brackets match, so that is now our common factor. And what's left goes in the other bracket. So I can put this back over here now into my working and say that P of x is equal to x plus 3, 2x minus 1, 3x plus 1. Now that's really handy to be able to do that, because now that would enable me to graph this cubic function if I wanted to, because now if I equated P of x to 0, I can work out what my 3x intercepts are going to be. So anyway, that's it for now. factorising polynomials. So you can use that same process if you had a quartic function or a polynomial of any higher order. You could keep repeating the polynomial division until you got down to something such as a quadratic that you could factorise using easier methods. So there you go, factorising polynomials. I hope you found that helpful.